Hello everybody, this is Bob Gilio again. So I'd like to have another project with you to talk about table saw safety. So one of the most dangerous parts of a table saw is to have the blade fully exposed like this without a guard. And while the guard is very important, it becomes very difficult to do a lot of woodworking procedures with it in place. So for example, if I was to use my new crosscut sled that you saw me build in a prior video, then you would know I could not use this guide in place. So I remove it and the blade would be fully exposed. But I get the extra safety protection by the reels and the blocks on the back to protect me from the blade being exposed. So I would remove it for that. But there are many other instances where it becomes a nuisance and almost, and a lot of times, impossible to keep it on to do certain things. Example is if I was to use the restored tenoning jig that I showed you in another video, you can see here, I can't use it with this because it's going to get in the way, and I have to completely remove it to use it with this accessory. So that's one example. But there's many examples that the guard becomes really in the way and you got to remove it. So another example is if I was to do a very tight ripping of a piece of wood, then you see the guard is now in the way. So it limits my ability to do very thin cutting of strips of wood with the fence. So another reason that I'd have to remove it. But it is very important to have it there. Like for instance, one of the biggest things it does for safety wise is not only does it protect me from accidentally putting my hands near a spinning blade that's very sharp, it also prevents kickback, which is one of the biggest, probably the most dangerous thing on a table saw, is when a piece of wood gets caught behind the blade. And when that happens, the reverse blade, the blades are coming out of the table, it will have a force that kicks the wood back and hits the person in the chest. And this has happened to me about twice in my life, and it's pretty dramatic and pushes you back pretty strongly. So that's why it's important to have it. So, but because of this dilemma that you really need it, but then again, you can't use it in many cases, I'm going to do a video on showing you a modified version of this. What I'm going to do is remove this and I'm going to modify it so that I'm going to still get a certain level of protection and safety, not complete, but you'll see that it's greatly improved than having the full guide in place, and it doesn't limit me from using all of the different accessories and practices that I need to do when I'm using the table saw. So my idea is to take the benefits of what I have here, this long splitter, and to use it but make it smaller. And the other thing that we have to talk about, which is the most important feature, is that the function of the splitter is to prevent the wood from coming behind the blade and getting caught on these back teeth here. But the problem with the splitter is that as you lower the blade like this distance grows greatly, and now it becomes easier and easier for the wood to go behind the blade and get caught. Start off with making new, what we call zero clearance blade inserts, which you can see here. This red blade insert is a factory one. And what we're going to do is we're going to cut several of these. As you see, I have these blanks. I made the blanks out of 1/2-inch plywood, maple face plywood. So I cut about 6 of these blanks, and they're about the size of this. They are bigger than the actual insert here. I'll show you. I cut the insert out. You see that I made them slightly bigger. So now I'm going to cut them down so that they're exactly the same size as this. And I'm going to use the blade itself now, the saw blade, to actually cut the slot by putting it in place and then lifting the saw blade up slowly while it's clamped in place. And I'll be cutting a slot exactly equal to the width of the blade teeth In this case, it's 1/8 of an inch. So that's going to give us a 0 clearance. Now, that has another set of safety benefits to it in that there is no space between the actual teeth and the slot. And so the two benefits of minimizing the space or making it go to 0 with this type of approach we're talking about is you get very nearly perfect cuts with no tear out at all, because the material is supported very tightly on both sides of the teeth as they cut, so you don't have any of those fibers being pulled down into the slot. You have very few of those. You don't even see them. So that's a big benefit to the quality of the cut. But also, if you're cutting thin slivers of wood, or you're just trying to true up a board and you end up with slivers, they can actually slide down into the slot, get caught around the blade, and start whipping around, which is not a safe situation to have. So the zero clearance insert will also improve the safety and quality of the cut. And one of the big benefits of doing this is that I can now, since I've cut multiple blanks, like I said, I can now custom make fins the shape like this. That's going to be between the new splitter that I'm gonna cut. I'm gonna reduce the size of this, and as this distance grows, I'll have one of these clearance inserts, 0 clearance inserts for different heights, and they'll have the fin, which will be cut by the blade itself, always giving me the minimum space there. To make a new version of this splitter, I basically had bought from Amazon this nice piece of aluminum, exactly 1/8 of an inch thick, and I'm going to be tracing this old or the original splitter on this, and I'm reducing the size of it to look something like this. I've kind of sketched out already. So you can see it's going to have this kind of shark fin on it, which is going to be the splitter. It's always going to be stationary. And between the splitter and the blade, I'm going to have a fin that's going to be different heights. And then you see I'll still have the 2-bolt pattern, so I have a very secure, fixed splitter in place, and I have that long distance of keeping the wood straight behind the blade. So I dismantled the factory blade guard, take off the components, so I can get at this splitter by itself, and I used it to trace out on the sheet of aluminum the outline of the bolt holes in the shape of the splitter, and then in combination with that, in my drawing, the reduced dimensions, and also I used a French curve to go ahead and draw this curvature here of the back of the shark fin there. So to cut the piece, I'm going to use a jigsaw with a very fine tooth blade, and I tape the bottom of the plate so that I don't scratch up the aluminum too much. Now that the piece is cut out, we're going to go ahead and take it on our sanding table and our drum sander and clean up the edges and get it right down to the black lines. Now I'm going to clean it up with a hand file. And that's just about it. Pretty perfect, pretty close to what the outline was. And now I should do some final smoothing on the fine sandpaper. And I think we're there. We have to drill a square hole. We have to machine out a square hole here for the carriage bolt that goes in the back. But we're just about done. To cut the square hole, I'm going to go ahead and drill a 1/4 inch diameter hole for the center, and I'm going to file this whole square. To finish the splitter, we want to put a sharp edge, a beveled edge here on the portion that goes right behind the saw blade, because that's why it's called a splitter, right? So it's going to split the joint open. Here's the splitter installed on the table saw. So now the next step is to go ahead and start cutting out this blank here for the new inserts, the zero clearance inserts. So I just want to point out to you, you see the space here between the teeth and the actual slot. And this is to allow different width blades to be used, with this way. So what we're going to do is we're going to take this out, and we're going to put it on our blank. And basically what we're going to do is we're going to just cut the width exactly. Now the width is a little bit over, so I want to make sure that it's exact. And what I'm going to do is I'm going to take my fence, like here, move it up to the side of the blade, and we're going just to use it as a guide for us to set the fence. And that will give me the exact cut. I'll lock the fence in place like this. Remove this and reinstall the insert. And now I have the exact width. So you see it's a little bit over. So we're going to go ahead and rip this down. And we're going to do the other ones as well over here. So I got 6 of them. We're going to go ahead and rip down to get the exact width of the insert. Now that we've cut the width of the blank to the exact size of the factory insert, we're going to now cut the ends around the corners here. I just traced out the factory insert on our new wood insert, and we're going to cut those out with a jigsaw, the curvature. And the finger hole we're also going to drill into the inserts, which we're going to do all the remaining 4 or 5 of them. And we are not going to use the same location for the finger hole as the factory did, because if you look here, you'll see that right here is a tab, a setting tab for where the adjustment screws for the factory inserts sit and get adjusted. And I noticed that if you put the factory insert into the table, you'll see that you're right over one of those tabs, so it prevents your finger from going all the way through. So what I'm going to do is I'm going to move the finger hole on our new inserts to right about here, centered right here, so that there's so much easier to get to, and there's, as you see, there's no obstruction there in your way. Now I'll take it over to the sander to smooth out the edges. Okay, we're going to drill a finger hole now. So after a little adjustment on the sander, we got a nice tight fit. So now the next step is to take the factory insert, and as you see, it has these adjusting screws on it, and these are basically to adjust the height of the insert to make it exactly even with the table surface. So we're going to do the same with on our wood templates, but a little bit different. So we're going to use this, put on top of our wood templates, and we're just going to tap it with a rubber mallet so we get the impressions of these 4 adjusting holes here onto the template. With the adjusting holes now marked on the inserts, as you see, we're going to now use 5/8 inch number 6 wood screws like this, stainless steel, and we're going to drill 3 32nd holes through each one of these, and then we're going to go ahead and counterbore slightly below the surface, because these screws are 5/8, which is a little bit more than the thickness of the insert, and then that'll give us just about the right amount of adjustment as we ground the tip down of the screw, so that we can then use it as an adjustment seat on the tab underneath the insert. So with the screw head being a 1/4 inch in diameter, I chucked in a 1/4 inch drill bit here, and since the length of the screw is 5/8, which is 1/8 of an inch more than the insert thickness, I'm going to drill down to the bottom of the screw, going into 5/32 of an inch adjustment on the screw height as I put this in the table, and then it'll also allow me to have the screw always below the surface of the insert. So now we're going to grind the tips of these screws off so they become the supporting points for the insert once it's in the table. So here's a plate that I test fitted with the screws. It looks pretty good. They stand up, they're proud from the surface, about 1/8 of an inch, which is what I wanted. So you can see now that they're screwed in, how they can fit into here, and just about give us an even, very even height to the surface, and I can adjust them up and down by about probably 1/8 of an inch. So that's came out very good. So here are 6 insert plates, and I have been thinking about the different uses that I'm going to use them for. So I thought 3 of them, which will focus on these 3 here, I'm going to not cut the kerfs into these with a typical straight blade, like a thin kerf blade. I'm going to reserve these for dado cutting. So that means that I don't have to cut any further. I can basically put these into the table saw, remove the knife in the back, and that way I can just bring up the blade, the dados, different thicknesses, and it would be cut custom for the job I'm doing. So that's why I'm not going to cut any further kerfs in these. For these 3, I've kind of thought about it. I want to do one that is a low height, a blade height, about a 1/2 inch maximum cut material, and then the 3/4, and then finally a full height where the blade is all the way up against the back of the splitter knife, and I don't need any insert at all. I'm sorry, any fin, plexiglass fin that we've been talking about. And here's a prototype, by the way, of one that I made already, just playing around with it. And here's the plexiglass fin that I glued in place. I cut and glued in place. And the way this works is it fits into here like this. Just like that. And you see now I can raise the blade up to about a maximum of a 3/4 inch cut, like that. So it kind of comes out of the table, just about there. and then that gives me that constant coverage. You see how the fin fits right in the back of the blade, and I got no space there, so there's no way a piece of wood can come behind there, and I could have kickback. So that's my thought with that one. I think it came out pretty good as a prototype. There's still some things I have to clean up on it, as you see. But the next two I want to do is one where the blade's at maximum height. So if I raise the blade up like this, you see that all I need is just a zero clearance insert, because I don't need any fin behind it, because this is very close to begin with. So there's going to be one of these I'm going to cut only back enough so that I can get the riving knife to fit, so it fits around the riving knife. So I'm going to do one cut like that, and then the other cut I'm going to go to the maximum, the minimum ½ inch level of height, right about there, and then cut the slot all the way down to about here, and then put in a fin to fill the difference. To make the cut into the wooden insert, I'm going to slide over the fence until the side of the fence is just equal, aligned with the side of the edge of the factory insert, and that way I know that the insert I made will cut the actual kerf into the insert at the exact location I need it to when I drop this one into the table. So I'm going to do this one basically just the distance I need to get this cleared, this knife cleared here on the insert. And then the second one I'm going to go all the way until I get to the center line of the blade, which will allow me to glue in a fin that I'm going to show you how to do. I have inserted the insert that has just the kerf cut for the knife blade, and then because the blade doesn't really go all the way below the table surface, it still won't allow me to push the insert down all the way. So what I'm going to do is I'm going to basically push down the insert while the blade is coasting down, and then slowly raise up the blade to cut the kerf of the blade into the zero clearance insert. Okay, now we're going to raise the blade through the insert. Okay, and this is the insert we're going to use from now on for the blade full height, where I don't need the fin in the back. And you see that I can lift it out. Let me just put this down a little bit. It's a zero clearance, so it's a little tight, but I think you get the idea. It looks just like this, and it will be used when I want to do cutting of very thick material when the blade's all the way turned up. So we will put in the adjustment screws once we sand it and finish it. So that's basically, this one's done. Now, for this one, we're now going to glue in a fin that goes in the back. So this is going to be the blade height for cutting 1/4 inch stock, a little bit more than 1/4 inch, but you get the idea. So bring that down just a tad. So that's what I'm going to use when I'm cutting very thin stock. Now I'm going to fill this space right here with the polycarbonate plastic fin. To size the fin, I'm going to use the maximum length here from the center line of the blade, height, the highest height of the blade here, back to the back side of the fin. And I'm going to have the fin go all the way up to the height of the bottom of this knife right here, so that it will come out and be above the blade, basically up like this. And the reason I'm doing that is because I want to have the most flexibility. So if I cut a big fin like that out of the polycarbonate, then I could easily make this, say, 3/4 inch insert into an inch or inch and a quarter, inch and a half. I'll have enough material of the Lexan or the polycarbonate so that I can just raise the blade up and it will cut into the blade up to the maximum height of this back fin right here. So that's why I'm doing that. Let's see how it works. So that's a detail we want to work out. So the material I'm going to use for the plastic fin behind the blade is this Lexan material. It's a polycarbonate and it is the thickness is about 3/32 of an inch. So a little bit slightly less than the blade thickness, my thin kerf blade being 1/8 of an inch. So I think it's a perfect choice for this because I can glue this up. It's very strong. I can glue this into the wood, and the strength of it will allow me to cut it with the saw once it's in place and the glue is set, and I can get a custom curvature of the saw blade cut right into the material and basically give me zero clearance for the fin as well, for the anti-kickback fin. I'm going to cut it with my jigsaw. And now I'm going to do the final shaping and smoothing of it on my sander, disc sander. To locate the fin into the insert, I'm going to place the fin into the insert, slide it back, and you see the curvature here is after I allow for the thickness of the insert, so that this will sit, the bottom of the insert will sit right totally into the full thickness. The bottom of this fin will sit into the full thickness of the insert. And so I'm going to allow for a little bit of clearance here so I can take it out. So when I take it out, I'll get the right movement. I don't want to put it right against it because then I won't be able to take it out. So I'm just going to put a mark right here, and that's where I'm going to glue the fin in. Now I can't push the fin all the way down because the blade is right there. So, but when I'm done, we'll raise the blade up and cut through the fin, but that's what's going to look like glued in place. So let's go and glue it. So here's the fin positioned into the vise, and now we're going to use some Gorilla super glue, because I'm using the super glue because I'm doing a plastic to a wood. If it was wood to wood, which a lot of fins are made out of wood, I would use wood glue, but this is going to have to be a super glue because I'm doing different materials. So I'm going to just apply it on the brush in the slot using the brush and glue it and clamp it. Okay, let that sit overnight and finish it tomorrow. So now that the glue is dried, here is the insert with the fin glued in, permanently installed, and now we're going to put it back into the opening of the table saw, and then we're going to lower it down so that the blade cuts the underside of it, and then I'm going to raise it up. move the fence over the insert just so it doesn't pop out of the table as we raise the blade up to a cutting height of 1/4 of an inch, which is going to be this thickness. Okay, so the final step is we're just going to shape this top of this fin to give it more of a shark fin shape to it, because we don't really need this extra material here. And I do want to use it in the future, that if I wanted to raise the blade up and make this a higher cutting depth for this particular fin, I can do it and the blade will just cut into it more. That's why I use the polycarbonate, because I can just cut into it anytime I want with the blade. So I just kind of soften this sharp corner here and this one as well. And I'll take that on the belt sander and just sand it down smooth. Here are the inserts finished for the dadoing applications. As you can see, I cut three different size dados, 1/4 inch here, 1/2 inch, and here's a 3/4 inch dado. Now I can go ahead and change the width of this dado and actually cut open these slots more as I need to, but it's very flexible. I get the 0 clearance here on the side of the blade, as you can see, to the insert, and the insert easily is removed. You can see the blade there, and reinstalled without a problem. The other detail I want to mention is there is no splitter in the back or riving knife, because with dadoing, you really can't use it, and you don't really need it because you don't cut all the way through the stock. You just dado a groove into it, so the chances of kickback are very, very low. So here are the 3 inserts for just simply ripping boards. And you can see now I have the splitter installed, and I did paint it a nice gloss black, sprayed it. And then here is the splitter itself. Now this splitter is for a 1/4 inch height on the blade. This is my min height splitter. So you can see how the fin, the clear fin here, fully fills this space between the front of the splitter and the back of the blade, which is the danger zone. So now you can see that no wood can get behind there, and these teeth can grab hold of and kick it back at me. So that is a big improvement. It's a big safety improvement. So and if I wanted to do a higher blade cut, then I made a splitter here. This happens to be for a 1/2 inch height, blade height. Now I can just raise up the blade like this. And you can see now I got basically 0 clearance again between the teeth and the fin, the plastic fin, the polycarbonate fin. So that was the whole idea. So because this splitter is fixed, I had to deal with this open space with the blade height changing, and that's how I did it. So I have 3 different splitters. 3 different inserts now with the fins for different heights of cutting. And then this fin here is for, this insert, is for maximum height cutting. And you'll see that I can now raise the blade all the way up until this gap shrinks to a very small, narrow gap. So anyways, you can see that the screws I used, for the different, each one has a set of leveling screws here, so you can see that they protrude from the back here, and they give you these nice standoffs so that you can then adjust the inserts to give you that perfect height to the blade, and you can adjust them in the future very flexibly. So they're easy to remove and take out, and it was a great project, and I've really improved the safety now when I'm doing my table saw work. So I hope you enjoyed the video, and thanks for watching.